Guys, this is the last video of the series, and we're focusing on question 10, which is all about probability. So what exactly do we mean by that? Well, we mean probability theory. We are talking about Venn diagrams, and of course, dear-old combinations and permutations. So these exam questions are from the Department of Education's November 2022 paper 1 exam. So here we have a Venn diagram with various probabilities filled in. And of course, we can see that we're given the event A, B, and C and their values, and then of course Y on the outside and X, right? So as A, B, and C are three events. The probabilities of these events or any combination of them occurring is given in the Venn diagram below. All right. So 10.1.1 says, if it is given that the probability that at least one of the events will occur is 0.893, calculate the value of y, the probability that none of the events will occur. We can see from the mark here that it's quite a simple question. And when we want the probability that none will appear, we mean the probability of everything, which is 1, minus the probability of what we know will occur, which is 0.893. And so we get the probability that none of those events will occur is 0.107. Right, and it says X, the probability that all three of the events will occur. So we know that all of the events occurring, or at least one of the events occurring, is 0.893. And so we know that the 0.893 adds up. And let's just go back up and look at our Venn diagram, adds up to all of these other probabilities occurring. So we'll add all of them together. And so I've written them down. So here they are. So it'll be 0.05 plus 0.15 plus 0.05 again, plus 0.1 plus x plus 0.2, and lastly plus 0.183. Sorry. All right, so we add all of this up, and so on the left-hand side, we still have 0.893 is equal to x, and we add all of the rest of them up, and we get a value of 0.733. And so we take the 7.33 to the other side and subtract it from 0.893. And so what we're left with is x, and x is 0.16. All right. So that's pretty straightforward. And so now what we'll do is look at 10.1.2, which says determine the probability that at least two of the events will take place. And so if we go back up our Venn diagram, we can see at least 2 is 0.15 plus 0.1 plus 0.2. We can see the overlap essentially. That's what we're looking at. So here we're looking at this value here, plus this one here, plus this one here, at least 2 events. And we'll add all 3 of them together, and we'll get a total of 0.45. All right. Next question says, are events B and C independent? Justify your answer. So now we need to find the probability of B. So if we go back up and look, we're going to add all of these together. So 0.1, the x, which is 0.16, the 0.2, and the 0.183. And this gives us a probability for B of 0.643. Now the probability of C is to add up all of these events here. And so we'll have 0.05 plus 0.15 plus 0.16, which is the x that we found, plus 0.2, and that gives us 0.56. So let me just do this side. So the probability of B we found as 0.643, and the probability of C that we found is 0.56. All right. Now the probability of B and C happening is going to be where B and C overlap. And so that is this part here. And so we'll add the two of those together. So that's 0.16 and 0.2. So the probability of B and C happening is going to be 0.36. Now, when we have events, we can say that the probability of B and C is the probability of B times the probability of C. And if we plug that into the calculator, we get 0.36. So we can see that the probability of B and C is equal to the probability of B times the probability of C. And so we can see that they are independent because they have the same values of probability. Right. So now we move on to permutations and combinations. So we see a 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. The digits may not be repeated. How many possible 4-digit combinations are there to open the lock? All right, so we've got 4 possible combinations, right? And so we'll draw this here. So 1, 2, 3, and 4. Okay. And the last one can only be 2, 4, 6, or 8. Right? And the other 3 possibilities are 2, because we can't have 0 and 1, 3, 4, 5, 6, 7, 8, or 9. Okay, so this means that in this slot here, we have 1, 2, 3, 4, 5, 6, 7, 8 possibilities. And we're going to take away these options because they'll be there. So one of those will not be in here. So that leaves us with 7. So it's going to be 7 times 6 for this one here, times 5 for this option. And our last option is 2, 4, 6, and 8, which is 4 options. So times 4. And so if you multiply all of that together, you get an answer of 804. Okay. Now, 10.2.2 follows on, it says, calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. All right, so going back to the original information that we have, means it's bigger than 5. So the possible answers that we have for here would be 5, 6, 7, 8, or 9, right? The third digit is 2 and only 2. And then that only gives us 3 options here, which would be 4, 6, and 8. All right, so here we're going to have so what we're going to do is do for 3 different possibilities for those 3 there, right? So we have 5 options, 1, 2, 3, 4, 5, that fits in here. And okay, so we have 5 options, and then we're going to have 5 options here as well. That's a 1, and that's a 1 if it's a 4, right? Then if it's we'll have 4 options times 5 possible options, which is this one here, times 1 times 1, and then we'll have plus, and then 4 different options times 5 times 1 times 1. Whoopsie, sorry there. All right, and so what we have is 25 plus 20 plus 20 is equal to 65. And so your probability, there are 65 possible combinations that meet with this possible solution. And so our probability will be 65 over 840. All right. So remember for probability questions that it's always a good idea to write down exactly what they're asking you for and what other information you have so that you know, okay, I'm missing a 2, I'm missing a 0, 1, I can use 3 and 4. If I'm not using 5, I've got the option of 7, 8, or 9, and so on. Okay, so just remember to play around with your probability, and the more that you practice these types of questions, the easier they will. Guys, thank you so much for joining us on this adventure of paper 1, and join us for our next series on paper 2, which will hopefully be up shortly.